Hello student, hi, good evening. So today we are going to see how to write the direct form 1 and direct form 2 for the given difference equation in discrete time signal. Okay, so let's see. So we are going to design here direct form 1 and direct form 2. So that is what. Let us take one question about difference equation. So this is my difference equation, y of n minus 2 y of n minus 1 plus y of n minus 2 is equal to x of n plus x of n minus 1. Okay, so this is my difference equation. Now what we are going to do, so we are going to design this difference equation by in direct form 1 and direct form 2. Okay, so that is what how to write the direct form 1 and direct form 2 for this given difference equation in discrete time system. Okay, so for this, first of all, we are going to calculate we are going to find the Z transform for this. Then after that we will draw direct form 1 and direct form 2. So representation. Let us first take the Z transform on both sides. That is what Z transform of y of n is nothing but y of z, and Z transform of this y of n minus 1, it is delayed by 1 unit. So its Z transform will be 2z inverse y of z plus this is delayed by 2 unit, so its Z transform will be here z minus 2 y of z. Okay, so similarly here is equal to Z transform of x of n is what, x of z, and Z transform of x of n minus 1 is z minus 1 x of z. Okay, so this is what Z transform for this difference equation. Okay, so now separate this, what we will get here, y of z take common, so this is nothing but 1 minus 2 z inverse plus here z minus 2, okay, is equal to here x of z into 1 plus z inverse. Okay, so now we are going to write what, transfer function. So let us write this here, transfer function for this. So transfer function that we get here, let's see. Transfer function is nothing but for this is h of z is equal to y of z upon x of z is equal to what is there term with x of z, what term is there, that is 1 plus z inverse, and the term with y of z is what, 1 minus 2 z inverse plus z minus 2. Yes, z minus 2. This is our transfer function. Okay, so this is what, transfer function, h of z is equal to y of z upon x of z is equal to 1 plus z inverse divided by 1 minus 2 z inverse plus z to the power minus 2. So this is what, transfer function. Now we are going to write direct form 1 and direct form 2 for the given difference equation using this Z transfer function. Okay, Z transform. So now see here how we will write. So we are going to write first, we are going to draw first what, direct form 1. So let's see how to draw the direct form 1 representation for the given difference equation. So this is what, direct form 1. So let's see first direct form 1 representation. So this is first we are going to write, we are going to draw the direct form, what, we are going to draw the direct form 1, we are going to write direct form 1 representation for the given difference equation. Okay, so for this direct form 1, the transfer function that we have obtained, h of z is equal to y of z upon x of z, so which is equal to this 1 plus z inverse divided by 1 minus 2z inverse plus z minus 2. So for direct form 1, what we are going to write here, h of z will be equal to what, h of z is equal to w of z upon x of z into y of z upon w of z, okay. So this is nothing but w of z upon x of z is what, w of z over w of z upon x of z is nothing but this forward path, this is nothing but 1 plus z inverse, and this y of z upon w of z is nothing but over feedback path, this feedback path 1 by 1 minus 2 z inverse plus z minus 2, okay. So this is over, this is feedback path and this is forward path. So therefore for direct form 1, first we will design this, we will draw for forward path followed by feedback path. So means direct form 1 means forward path followed by feedback path. So how to draw it, let's see. So first, so what was that? H of z is equal to forward path. So this is my what, forward path, w of z upon x of z into feedback path y of z upon w of z, okay. So this is nothing but what is forward path is first 1 plus z inverse, this is my forward path, this is followed by feedback path 1 by 1 minus 2 z inverse plus z minus 2, okay. So this is what order that we should follow. Now how to draw this direct form 1, okay. So this is what, here we will take first summer, this is my summer, and here I will apply what, x of n, this is my x of n, and here first we are going to draw what, forward path, this is my forward path. So let's see here, somewhat here, this is my forward path, yes, this is my forward path. Here it will go like adder, by the delay of how much delay is there, z, delay of unity. So this is delay by 1 plus z inverse. Now we have to add this with this, okay. So this is what, adder with gain of 1, this is 1 plus z inverse, this is 1 plus z inverse, yes, here this is what, 1 plus z inverse. Now this forward path is followed by what, feedback path. Now here we have to draw the feedback path, yes, feedback path. The forward again, here is what, 1, then here is output yn, and here feedback is what, feedback is delayed by 2 unit. So this is z minus 1 and this is my z minus 2, and I will add these 2 delay with summer, okay. So then I will apply the feedback, this, let's say this is negative feedback and this is my 2 feedback, one feedback this and another feedback is this one, okay. So sum of two feedback, okay. So this is first you see what is the gain here, feedback gain minus 2, so that I will apply here minus 2, and what is here, feedback gain, so this is actually z minus 2, okay. Gain is what, 1, gain is 1, here 1, gain is 1. So this is what, this is 1, okay. Now this is what, this is the direct form 1 representation, this is what, direct form, this is direct form 1 representation for the given difference equation that we have wrote at the first time. So this is what, direct form 1 representation for the given difference equation. For direct form 1, what we should remember that direct form 1 is always what, forward path followed by feedback path, okay. Forward path followed by feedback path. Here this is what, here this is w of z, yes. First we have drawn this w of z upon x of z, then after that y of, this is w of n, yes, then y of z upon w of z. So this is my direct form 1 representation, okay. So in short, what you have to remember that the direct form 1 is always forward path followed by feedback path. First we have to draw forward path, this is my forward path, then after that we have to draw the feedback path. So this is what direct form 1 representation. Now we are going to see the direct form 2 representation, okay. Direct form 2 representation. So for this, what we have to do, so we just reverse, okay. We just reverse the direct form 1 to make direct form 2. So this is how, see, direct form direct form 2 representation. Okay, direct form 2 representation for what? For y of n minus 2 y of n minus 1 plus y of n minus 2 is equal to x of n plus x of n minus 1. Okay, x of n minus 1. So this is difference equation. Okay, so we are going to draw for this direct form 2 representation, as we have obtained h of z is equal to what? H of z is equal to y of z upon x of z, that is equal to 1 plus z inverse divided by 1 minus 2 z inverse plus z minus 2. Okay, so for this what we are going to write h of z as for direct form 2. So h of z for direct form 2 is nothing but this is y of z upon w of z into w of z divided by x of z. So this is what? This is my feedback path and this is my forward path. Okay, here feedback path followed by forward path, which is just what? Reverse, which is just opposite of direct form 1 representation. Okay, so let us draw this direct form 2 representation by what? By feedback path followed by forward. This is by feedback path followed by forward path. Okay, so now let's see how to draw this direct form 2 representation. Direct form 2 representation. Okay, so this is here what? H of z is equal to what? H of z is equal to y of z upon w of z into w of z divided by x of z. Okay, so which is nothing but what? 1 plus z inverse, which is nothing but first is what? 1 minus 2 z inverse plus z minus 2. Okay, so then 1 plus z inverse. This is feedback path followed by forward path. Now see here feedback path. So this is my feedback path here and here feedback path. Okay, so this is my feedback path here. This is my feedback path. This is my x of n. Okay, so this is feedback path. Here delay in feedback is what? Two delay is there in feedback path. This is z minus 1 and this is my z minus 2. Okay, now sorry, feedback path is not like this. Feedback path is here is summer. Okay, and here we are going to apply x of n input, and here we are going to apply feedback path. So this feedback is delayed by 2 unit. Feedback path is delayed by 2 unit. So this is, and these two feedback is going to add with summer. Okay, so then here we are going to take feedback. So now this is negative feedback. Now we are assuming this is negative feedback, and here gain is what? Gain of first feedback is minus 2 negative feedback. Gain of next negative feedback is plus 1. Okay, now here we are going to, so this feedback path is followed by forward path. What is my forward path? Here with gain 1, this is my forward path. Okay, so with delay of 1, so this is my forward path with delay 1. So this is what? Here gain is 1, so it is delayed by 1 only, and here output is what? Y of n. So this is my direct form 2 representation for this difference equation that we have drawn here, which is just opposite of what? Direct form 1 representation. This is feedback path followed by forward path. So direct form 2 is nothing but feedback path followed by forward path, whereas direct form 1 is forward path followed by feedback path. Okay, so then what is the difference between direct form 2 and direct form 1 representation of difference equation? So the difference is nothing but here, if you see in direct form 2 representation, number of delay get reduced. Yes, number of delay get reduced, whereas if you see in direct form 1 representation, there was number of delay, how many? 3 number of delay was present in case of direct form 1, but here in case of direct form 2, number of delay required is only 2. So therefore we can say that the difference that we find between direct form 1 and 2 is that number of delay in case of direct form 2 is less than the number of delay required for direct form 1 representation. So that's all about this difference equation, how to draw the given difference equation in discrete time system by discrete time system by direct form 1 and direct form 2 representation. Okay, so thank you very much. Thank you.